on this voltage would depend upon, see here, if you see, there is some potential energy to it, with what height is it is falling. So this is some potential energy involved, and the force of the water will be the kinetic energy to it, and the pressure of it is basically the voltage. So suppose I tell you I have a pipe over here, and this pipe is like this, okay, and I am putting water over it. So I put 5 liter water, okay, so only 5 liters will flow through it. Now what I say is I have pipe here, okay, so I have one more connection over here, one more tap over here, and one more tap over here. And these taps are measuring, this can carry 3 liters, okay, this can carry 3 liter, okay. So what I do is that I have a tank over here and I fill it 6 liters, okay. So that means water goes, 3 liter falls here and 3 liter falls here. So current is getting divided, okay. Suppose it was 6 liter tank, okay, and this capacity was 4 and this was 2, then that 4 liter will fall over here, it will get filled 4 liters, and remaining will flow through this. So same principle you are going to understand. So now if you have to define Ohm's law, hmm, so any one of you can you define me Ohm's law? Yeah, tell me. Yeah, Khan Waqas Javed, you tell me what is Ohm's law? Yes. Yeah, Ambika. Hello. Anyone? Mehul. Mehul.
So Ohm's law is basically the potential difference between 2 points is equals to current into resistance across the 2 points.
See, this is you are defining this equation. V by I is equal to R. Okay. But how did Ohm's law originate? Okay. So please listen carefully. Ohm's law states, okay, that at constant pressure, because this resistance over here, it depends upon the material, like carbon, semiconductors, different materials have different coefficients of resistance, okay. Conductors will have coefficients of resistance, means how it varies with respect to temperature coefficients, like temperature coefficients, okay, temperature coefficient. So this means how resistance varies with respect to temperature, how resistance varies. If it is having positive temperature coefficient, means if temperature increases, resistance increases, temperature decreases, resistance decreases. How resistance varies with respect to, with respect to temperature, okay. So this is one essential thing. Certain conductors will have positive coefficient, okay. Insulators and semiconductors, different devices have different coefficients of resistance. So more or less, okay, Ohm's law will state us, here I'll rub this, so you might have taken, so this equation you just defined, hmm? So Ohm's law, now it is about Ohm's law, okay, yeah. So Ohm's law states that at constant, okay, temperature and pressure and atmospheric pressure, because atmospheric pressure plays a very vital role in every item. Atmospheric pressure, even if you go as a human being to the Ladakh region, you have to like acclimatize before going out, because there is a different atmospheric pressure. States that at constant temperature and pressure, the current density, when I say current density, that means current divided by per unit area, that is J is equal to current divided by per unit area, is equal to the electric field gradient. Okay, yeah, any doubts you're having? So this is how an Ohm's law an electrical engineer will define. So that would mean your J is equal to sigma E. Okay, where this is equal to 1 by rho. This is the resistivity of a material. Okay, resistivity of material. Yeah. So this is what Ohm's law states. So this J value, I told you, let me write this as equation 1. So this J value is I by A is equal to sigma E. Okay. So you, if you you can write, if E is EMF, E can be taken as V also, no problem. You can either write E by I is equal to R or V by I is equal to R. So here if you notice, that is the gradient. Sorry, this is E by E by L. Okay, where is equal to electrical field gradient. This is voltage or unit length. Okay, so this thing you have to take into consideration. Equation 2. Now what you do is that, now how do you express? Now you can write this in terms of quantities, in terms of cross multiply it. This will become E. You have to keep, there it is. So E by I, here is E, here is I is equal to, this is 1 by rho L, because the sigma is 1 by rho L, and this E by I is equal to this. This will become 1 by rho L into E, and this becomes, sorry, this becomes I by, yeah, I by A. So you can write this in terms of I by E is equal to A rho L, or in other terms, if you reverse, if you see what is this, E by I is equal to R, and I by E would mean 1 by R. Okay, this is I by E would mean 1 by R. So this is 1 by R is equal to A rho by L. Okay, in other terms, this is your equation 2, equation 3, this be your equation 4, equation 5. Now in other terms, how do you write over here? So from this equation 5, you get your R is equal to, because R, now you have to reverse this, rho L by A. So this is the thing, resistance is equal to rho L by A. So you have seen this, R is equal to rho L by A. This is what an Ohm's law is stating. At constant temperature and atmospheric pressure, the current density is equal to the electrical field gradient, wherein your J is your current density, and from these equations we have arrived at this particular equation. Okay, so any doubts you are having, anything you tell me, please let me know.
Sir, can you please repeat the equations once again, sir?
Okay, okay, I'll again, no problem, I'll repeat it. Okay, I'll for your better understanding, I'll rub those
Step 3,
equations.
sir. Excuse me, sir.
Yeah, tell me, and I'll repeat. Yeah, tell me.
Sir, in law, the current density is proportional to electric field gradient or equal to?
No, uh, it is proportional with the material. This with the constant, because I have written is equal. We can say the equal to the electrical field gradient with respect to the material constant. That is your sigma. So it is almost can be said it is equal to with respect to the material what you are using.
Is
Okay.
directly proportional to electric field.
Yeah, that is, you can write that also, no problem. Directly proportional, like in the resistance equation also you are writing, no problem. But equation some of you have not understood. So this is like if you have to write like this in the starting, J is directly proportional to E by L. Okay, but J is equal to, because see why it's writing proportional.
Constant sigma.
This value sigma E by L. Okay, so this particular sigma value depends upon the material. So gold will have different, silver will have different. Okay, the sigma value is nothing but as 1 by resistivity of the material. Okay, so this value is depends upon the resistivity. So now you can see it. This is sigma E by L. Okay, so this is the equation 1, and from this particular equation only you will write current density J value is equal to I by A. Okay, is equal to sigma E by L, equation 2. Then from here you can write, okay, if you want to write like that also, see what I do is that nothing I do, I have done like this. I by E is equal to A sigma A by L. Okay, this is equation 3, and I by E is equal to 1 by R. So this is my 1 by R. 1 by R is equal to sigma A by L. So this is my equation 4, and I have already told you sigma is 1 by mu. So I can write R is equal to L by sigma A, where my sigma is 1 by rho. So 1 by rho, it will go up. R is equal to rho L by A. My equation 5. Any doubts you are having? Now you are having, now you understood? Yeah. Tell me, Guru Kiran. Rahul.
Yes, sir.
You understood?
Yes,
So,
sir.
now you understood, na?
Yes,
Okay.
sir.
Okay. Nice. So let's. This was about the Ohm's law. Okay. So let's go into a more detailed circuit in today's class. Let's understand about some sign conventions when we are using an electrical circuit or drawing an electrical circuit. So we have to pay very much attention to what type of sign convention that you are using. Okay, so this derivation you must have already studied or not. You have studied first time or you had already studied this?
We have already studied, sir.
Yeah, because these the definitions are there, some basics would be there. That's what. Okay, now one more important thing over here is, let's go to certain things. This is the sign conventions that we are using. I think this would be a little new for you. Maybe sign conventions. Okay, sign conventions means how to put or consider voltage, polarity, and current direction in a circuit. Okay, now I will make a circuit. Okay, this is plus, this is minus. So let this be the direction of current is like this, I. Okay, so you see this is negative, this is positive. So negative does not mean, suppose if you have a battery at your home. Okay, this is a battery, suppose this is 3-volt battery. So it is plus sign over here, minus sign over here. So minus sign does not mean it is 0 volts, or plus sign does not mean it is 3 volts. Minus sign means only it's at lower potential, it's at higher potential. So this lower potential can be 2 volts, this higher potential can be 5 volts, and the potential difference across them, that is 5 minus 2 would be 3 volts. It can be anything, 6 and 3 also. So what I say is this is my lower potential, and here I say this is my upper potential or higher potential. So you can see the current is moving from lower to upper potential. So there is a rise in potential. Okay, a rise in potential. Okay, so when there is a rise in potential, this phenomena occurs in an element that is releasing power or releasing energy. Okay, this phenomena occurs in elements that is releasing power. So like our batteries. Okay, torch, other elements that are releasing power. So usually what happens is that when you are applying KVL, KCL, you will say we will take an arbitrary direction, and then after solving the problem, if it's coming negative, we'll take positive. Okay. But what I suggest is that instead of taking an arbitrary direction and solving the problem, let's stick to this. Let's consider the rise in potential as positive direction. So we'll take the value of rise in potential as positive. Okay. So this rise in potential positive, this is called as, here it is called as active sign convention. It's called as active sign convention, and this active sign convention is associated with, this is associated with, okay, energy delivering or releasing, what we can say, releasing elements. Okay, this is called as active sign convention. Now let's suppose the other circuit. Okay, the other way around, we have this plus, we have this minus. So this is my plus upper potential, this is my lower potential, this is HP, this is LP. Now what happens is that I take a different thing. I say that my current is going from here to here. Okay, so this is called as fall of potential. See, the current is moving from higher potential to fall of potential. So where is the fall of potential? See, when you are switching on your geyser, okay, or your hot iron, that is electrical press, or today cold weather, some people might be using blowers, or certain TV, fridge, certain equipment, or any other load in, you will see there is a dip in the light. If you are putting something in your house, you notice it. Why? Because the element you have switched on, it is taking energy, it is absorbing energy, and the absorption of energy is like fall of potential. So this phenomena occurs in element that are absorbing energy. So we'll say that this phenomena occurs in elements that are absorbing energy, like bulbs, okay, heating elements, like somebody, you must be having those induction heaters, other things, okay, and it is associated with passive sign convention. And what we will do is that this is a fall of potential. Whenever we have to consider, let's consider this is negative, okay, in a circuit. So are you having any doubts? You tell me, please. Have you studied this thing before? Yeah.
Sir, how bulbs will be absorbing elements, sir?
Bulbs don't generate electricity, okay. A bulb in itself does not generate electricity. Whenever electricity it takes, so it absorbs the energy and it produces two things. It produces light as well as heat. So it is an energy dissipating element. It is not an energy releasing element, okay. Once the power goes, does bulb release any energy? So
Then in torch, sir.
in the torch, it is not the bulb that is releasing energy, it is the batteries that are releasing energy. It is the releasing, and when you are switching on the torch, the batteries are releasing energy, and at the same time the bulb is absorbing energy. You are getting my point. Now if I draw a circuit like this, okay, nice question. Suppose I have a battery, this is my battery, okay. See here, yeah. Oh, okay, yeah. Notice this is my battery, okay. This is a battery. This is a bulb over here. Let me write, this is a bulb, okay, and this is my circuit, complete circuit. So this is the bulb that is here glowing. So this is my plus, this is my minus, okay. What I see is that my here it is plus, here it is minus. So how my battery, see here, how my current direction, minus to plus, plus to minus. This is the complete circuit. Okay. So what happens is that here the active sign convention, there is a voltage rise over here. Voltage rise. Okay, it is going from minus to lower potential to higher potential. Wherein here there's a potential fall, HPLP. So all the elements that you have connected in your house that in itself don't generate any electricity, be it your hot iron press, be it your bulb, be it your electrical geysers for that heating your water or anything else, it's a load. It is a load. All of these elements are energy absorbing elements because they themselves don't generate any energy. So what you see is that when you are making a torch, this is a circuit of a torch. So herein you see a battery is connected. If you remove the battery from the torch, will it produce any light, Manoj? If I
No,
remove the
sir.
battery, so is battery is bulb an energy releasing element?
Mm.
Huh?
Sir?
Is bulb an energy releasing element?
No, sir. Absorbing.
So got my point.
Yes, sir. Got it. Sir,
Uh,
but
uh,
battery's positive terminal is connected to bulb's positive terminal, sir.
no, not like that. See, you don't get confused like that. Bulbs positive. Bulb has no polarity. Have you seen in any bulb there is positive, negative like that?
No, sir.
Have you seen? It is not positive or negative. It is.
But
It is.
you wrote in circuit, no, sir. But so I asked it.
Yeah. To circuit, I wrote to make you understand how it is happening. So what is like whenever I will consider a bulb, okay, because I know that a bulb is an energy absorbing element. That's why I wrote plus minus over there. I know it is an energy. It will be by default like that. See,
Okay, sir.
you understood because I know
Yes,
that
sir.
if I'm connecting bulb, it will not produce energy. It will only absorb. That I
Mm.
know. Okay, and
Yes,
the
sir.
energy it will absorb depends upon its wattage. For example, it's a 20 watt, it will take less energy. 100 watt, it will take more energy. My meter will show more reading. Okay, so if you notice the electricity meter, there is some red light over there. If you are connecting more heating loads now, it will blink more faster, that red light, and my meter will run fast. So these are certain practical things about electrical engineering. So these concepts are see, same physics concept but in a more lucid manner in electrical engineering way point of view. So if it is looking little new to you, so it will take some time. Means, have you studied these things? You have not studied na in 12th and all.
Studied, sir, but not at.
Okay, not at this matlab, yeah, because they
Yeah.
are physicists. Okay, now no problem. So this is like now you must have studied voltage, how it divides and how current is remains same in series, how voltage is same in series. Now after understanding this concept, let's understand a circuit. Okay, so what we see is that if we KVL KCL will move next class. Now today we are focusing on Ohm's law. So now let's consider a circuit. Okay, let's connect a battery. Okay, this is a plus, this is a minus. Let this be resistance 1, let this be resistance 2. Okay, nice. We have, now remember one thing, whenever you see any circuit, okay, this is my voltage. So the first point A, label this. Okay, so the labeling will not change until and unless any element is in between. So label, note this point, nota bene, this is point of importance. Okay, nota bene is a foreign word, okay, for saying important point. Okay, so this you label the, and this point is called as node. Okay, label the node point, hmm, and the labeling does not change until and unless any element is in between. Now I will explain you the meaning of this point. This is, let this be over here. Okay. What does that mean? That means whenever I see this is my voltage source, I have to label a point. I'm labeling this point A, and this point is A till here. But now it will change. Now if I have to label this point B, this point B will remain till here, till here, till here, until unless there is no element. Whenever there is an element, the point will change. Now this is C, it will remain till here. Now you notice here, there is no element. Okay, there is no element connected, so there is a junction of wire. So when the junction, there is only junction of wire if there is only junction of wire, the label point will not change. The label point will remain same. Point will remain same. Why I am teaching you this? To make you understand. Some of you have sometimes what 90% of you might be knowing, but 10% may get confusion how to identify whether a circuit is in series or is it in parallel. So for that purpose, so this is labeling. So this will not change. C. There's again wire. So this point remains same. C. Now you see over here, if I write this D, is there any element in between? No element. So this is D. Any element between? No element. D. So this whole point till here remains same. So same it is remaining. Now if you go to a laboratory, if you have to rig up this circuit, so how do I rig up this circuit? What I will do, first I will connect like this. The other color I will use to make you understand. So let's take a green color. First I will connect all the elements that are in series, like this I will do. Okay, I'll connect like this till this point. This from plus to minus. Now I have connected A to this resistance R1, resistance point to B. Okay, then from B point to C. Okay, then C I have connected to the resistance other side, this resistance other side, then this D point to this D point, D point, D point, D point. So this is how I rig up the circuit, like this. I go in one direction and I connect the circuit. Okay, it is not that I will do this, then do that, then do this, then do that, and I miss some point and I get confused. So you have to, whenever you are connecting a network in a laboratory, inshallah that is going to happen soon. So at that time you have to pay attention. Now I was very much interested in this circuit. This is R1, this is R2. Okay, now this you might have already studied, voltage division rule. Okay, so how does voltage divide?
Based
Yeah.
on the resistance.
Yeah, how does voltage divide? Based on the resistance. How does voltage divide? Based on the resistance. Yes, it's correct. So in this circuit, if I want a voltage over here, okay, so basically what happens is that my voltage of the circuit V would be equal to VR1, that is the voltage across the resistance R1, and plus VR2, that is the voltage across the resistance R2. So this would be voltage across resistance R2, voltage across resistance R2, and this would be voltage across resistance R1. So this I'll rub over here. So I was explaining you the Other part. Okay. So I write my V is equal to VR1 plus VR2. Okay. Now similarly, like a tank, I said you, I have a current over here. Okay. So the same current is flowing. Okay. Because this is my tank. This is my tank. There's 10 liters water, and I'm flowing a water through. This is another tank. Okay. I don't know the capacity. This is another tank. So how water will flow? Water will flow, same water will flow. 10 liter will go through this, 10 liter will go through this also, because they are kept in. Suppose I have kept this is my water. Okay, this is a tank, 10 liter tank, and I kept another tank or straight. So 10 liter will enter this tank, okay, and leave this, and 10 liter will enter this, leave this, and will get flowed like this. So this means water flow is remaining same. Okay, the current in the circuit will remain same. So this was a different analogy to make you understand practically how it is done. Okay, so this is a practical approach towards electrical engineering so that you get a feel of it. Are you getting the feel? Yeah. If you're huh? Yeah, Mehul. Yeah, you are getting the feel. Yeah, let me know. Yes,
Yes, sir.
Mehul.
Yes, sir.
Yes, sir.
Yeah,
Yes,
nice.
sir. Yes, sir.
Yeah, you made my day. So what is exactly? So what I say is that this V, this is the total V, would be equal to current into the equivalent resistance. Equivalent resistance means the total resistance of the circuit, R equivalent, because the current is remaining same. So VR1 current is same. VR1 is equal to, see, potential is equal, V by I is equal to R. So V is equal to I into
Yeah.
R. Okay. So we say VR1 would be VR1 I into R1 plus VR2 would be I into R2. I we can take common. So I we can take common. I R equivalent. I can take common R1 plus R2. Nice. So I will get cancelled. So R equivalent would be equal to R1 plus R2. So you got this. Okay. So that is one thing we proved, that resistance in series is equal to summation of the total resistance. So this is one thing. Okay, in series, so we can conclude this is very elementary. You have studied in 10th also. So in series, resistance add up. So now about the voltage division rule. Now if I have to write VR1, VR1 is equal to I into R1. Okay, but if you see my V, that is this voltage V. V is basically what? I into R equivalent. Now if I have to write this I in terms of these, I can write I is equal to V by R equivalent. Okay, here instead of I, if this is my equation 1, this is my equation 2, I substitute 2 in 1, substitute 2 in 1. So I can write my VR1 is equal to, instead of I can write V by R equivalent into R1. Okay, so this VR1, how can I write now? So R equivalent I know is R1 plus R2. Okay, so I can write VR1 is equal to V R1 plus R2 into R1. So this is the voltage division rule that I'll write down over here also. My VR1 is equal to V, okay, into R1 plus R2. Similarly, if I have to write VR2, yeah, tell me, VR2 would be, yeah, tell me, Mehul, tell me, VR2 would be in case of VR2,
VR2 is V upon R1 plus R2 multiplied by R2.
wrong. VR2,
VR2 by
we see,
divided by
see,
R1 plus R2.
V minus VR1.
See here, see here, see here, see here. See, the problem with you people are that you are trying to solve the problem. We have to understand the technique. Okay. Everywhere, if you are even doing your computer engineering, don't learn a program by just learning that program, but understand the eventualities of it. Once you understand it, then you are able to create new things. Okay, engineering should be taken in that sense. See, VR1 you wrote now. Similarly, you write down first VR2. What is VR2? Here, VR2 is the current I is remaining same, I into R2. Okay, then what is I? I is V by R equivalent. So VR2 would be equal to V by R equivalent R2. Now what is R equivalent? R1 plus R2. So you can write V by R2 R1 plus R2. So one thing is that in the voltage division rule, simply if you have to see the voltage over here, so that is voltage multiplied V into R2 divided by its equivalent resistance, if you don't have to calculate it. Okay, now let's do a simple problem. Okay, so there is something called as gain. Okay, if I have to check the gain, okay, see, just now I saw just now we saw that our V was equal to VR1 was equal to V, okay, R1 plus R2. Okay, so VR1 by V would be equal to R1 plus R2. Or if I have to write this in other terms, VR1 by V, if I divide by R1 and divide both the sides, multiply and divide by R1, so I can write I1 R1 cancels 1 plus R2 by R1. So what I have done, I have divided by R1 here, I have divided by R1 here. Okay, so when I divide by R1 divided by R1 1 and R1 by R1 1 plus R2 by R1. So this is the gain, voltage gain. So can you tell me where the voltage divider circuit is getting applied? Yeah, can anybody tell me? Now you have understood this voltage divider circuit. So can you tell me the voltage divider circuit? Now if you have to write in this thing in terms of output by input, suppose you have to write it, this was like your output is, if your output is V and you have to do V by VR1. Okay, this would be the actual gain, because the gain is like your output voltage, that is the battery voltage, that is getting connected toward the absorbing element, and in that case it would be V by R1. So here you saw that your V into R1 plus R2 was equal to VR1. In that case you write V by VR1 would be equal to how much? Tell me. V by VR1. Now this you brought down, this you kept here, you can write R1 plus R2 in by R1. In that case it's 1 plus R2 by R1. So this would be again when you are considering this particular circuit. So now a question, as I'll put you a question. Let's see. See, basically where it is used, in the circuits where it is used. Okay, what is the popular application of this? See, in the physics lab you have seen in a potentiometer you are changing the resistance and all that, so a voltage divider network is getting consumed. Okay, so another position of it, you tell me, have you seen the car when rain falls, there is a wiper? Okay, sometimes you are making the wiper run at a faster speed, then at sometimes you are making the wiper go at little slower depending upon the rainfall. So how does it happen? Yeah, Tell me. Mehul? Why the class is so silent? Mehul, yeah, Keshav? Manoj? Are you listening or not?
Listening, sir.
So what happens when the rain is falling? Because I'm not making it only about electrical engineering. I'm telling you the practical applications of it. So I'm making it a little interesting. So when the
Through
rain falls,
battery is
so how
connected, sir.
battery is connected. So how the speed of the Viper is getting controlled? This, it is
Vmax
By
so
the
regulate
flow of
mm,
electrons.
no,
by the
it is by the voltage divider circuit. There is a divider network connected in between.
Okay.
There is a switch connected in between. So what happens is that, see, when you see this, you have this battery connected over here, and there are different resistances in series. Okay, and there is one switch over here. Okay, switch is over here. Switch position is here, wherein it has toggle 3, and that is your in your hand. You are moving it here to 1, so it is getting associated with this point. So when it is getting associated with this point, all the resistance come into play. So when all the resistance come into play, equivalent resistance becomes like this: V by R2 R3 plus R4. So that means current goes down. So it will move at knob 1, it moves little slowly. Then another knob comes into play, switch 2. So this means it gets connected over here. This is now not into play. In that case, it is R2 R3 plus R4. Current gets slightly increased. Then there is switch like here. In that case, there would be only R3. Then there's the final switch. So V by R4. So only V by R4 means current is very high and it starts to rotate at a faster rate. Now you got my point. Have you analyzed such certain simple things like the Viper control would be utilizing a voltage divider network? Huh? So,
yes sir.
these are the things. And now one more application of this is a popular application of variable attenuation. So this is also called as see, with voltage divider circuits. Yeah, with voltage divider circuits, variable attenuation is achieved. What does it mean? What does variable attenuation means? See, basically what it means is that, suppose you have to control volume in audio equipment. Now you are sitting in a car and you need to control volume in an audio equipment. So in audio equipment, in order to control this volume, you need a potential divider circuit, just like the thing where your this voltage is typically the signal from the preamplifier, and your input voltage where input voltage is signal from preamplifier that there is an amplification circuit connected over there. If you amplifier, and V naught is the signal sent to power amplifier. Okay, now this is voltage control and other thing over here. So we have to do some problem like voltage divider. Let's do one simple and problems, and I'll give you one homework for today's class. So yeah, this is a problem that I'm going to do. Let's take the new page next. Okay, the problem is, design a divider circuit which attenuates which attenuates a 15-volt source to a 5-volt while drawing a current of I is equal to 0.5 milliamps. Yeah, can you do this? See, what I'm asking you, you have to design a circuit, okay, which attenuates a 15-volt source to a 5-volt source. So what does that mean? See, one very important thing you please note, please note this when you are doing any problem. Note this, see, voltage will be always in volts, okay, current in milliamperes whenever you are solving any problem, milliamperes by default, okay, amperes, and your resistance would be in kilo ohms, so this point you have to notice. Okay, now you try doing this. See, how do you do about it? So it says that, okay, so if you see the ratio that you just now, I have shown you one equation here. Where is it? I think yes, here. Yeah. So here you saw an equation where V by VR1 is equal to, this is the gain. So it is giving you that from this equation, the upper is 15, the lower is 5. So if you see this equation, you can get a relationship between R2 and R1. So from this very equation, you can go for it. So yeah, so the problem I'll keep here. Where is the problem? Okay. Yeah, here it is. So how do you go about this? Yeah, some of you you should be able to do it. Okay, so what we see is, we can write that, we know that 1 plus, okay, R1 divided by R2 is equal to how much? Is equal to V1 by V0, that is 15 by 5. So you can say 1 plus R1 by R2 is equal to 3. Okay, this is one thing. Okay, the second thing over there, okay, from this very equation, what inference you make while drawing? See, design a divider circuit which attenuates a 15-volt. Basically what you need is that you need the value of R1 and R2. So that is what it is asking. So how do you calculate the value of R1 and R2? In other terms, if you say that this is the outside, this is the output voltage, okay, so I can say my V is equal to I into R equivalent. Remember one important thing, voltage division rule is applicable only in series network. This is another point. It cannot get applied everywhere. Okay, so voltage division is applicable only in series network. So in series network, the resistance would be R1 plus R2. This is R equivalent. So we can say V is equal to I into R equivalent. So I value he is given 0.5. So this V value we know 15. And now we have 0.5 R1 plus R2. So from here we got one relationship, R2 plus R1. Okay, R2 plus R1 is equal to 3R2. From this relationship, if we see R1 is equal to 2R2. This is one relationship from this particular equation. Okay, this is from here. If we write this equation 1, equation 2, and finally from this solving we get this value, equation 3. Now here is another equation. So this is 15 divided by 0.5, that's 5 into 10, so this is 30. So 30, r1 plus r2 is equal to 30. So if you substitute the r1 value, so from equation 3 to equation 4, okay, substitute equation 3 in 4, so what value I get? I get 3r2 is equal to 30. In other terms, r2 is equal to 10.
R2 10, R1 20.
So r2 10, r1
20,
r2
20, sir.
20. So r1
R2 10, R1 20.
20, sir.
20. Yeah. Actually, yeah, correct. You are correct. Little bit mistake over here. So what you do is that you put the value of this r1 plus r2 is 30. So you'll get the value of r1 as 20. Okay, where is it? See here. Again, r1 is equal to 2r2. So r2 value
10.
2r2. See here, 2r2. Instead of r2, you will put 2r2 plus r2 is equal to, here you put 30. Okay, so this is 3r2. So r2 is 10 and r1 is equal to 20, right?
Yes, sir.
Yeah. So now we will conclude this session. So you have understood. So what we did is, so this is a homework for today. Okay, tomorrow's class I'll be checking. So please try this. Design a voltage divider. Design a voltage divider. Design a voltage divider with a gain of 0.1 volt. Okay, volt per volt, because gain will have no dimensions, because volt up and down also volt na, and such that it absorbs 1 milliwatt, such that it absorbs 1 milliwatt of power when Vi, that is V input, is equal to 10 volts. Now here also we need R1 and R2 values. This is the homework. Okay, so please raise your hands for attendance. So how many are there? 47 people are there. So 47. Yeah.
Sir, can you please suggest some books?
Yeah, one book that you can go for is Charles Alexander Sadico. Okay, and actually, and there's one book by DC Kurukshetra. I have shared a link. Okay, wherein you can find some notes and books. Okay, PDF books also. But I will suggest you, this book is good. And please don't purchase these books, SC Chand books, na, or these are all commercial books. BL Thareja, avoid these books. Okay, so these books I don't like, because it will confuse you a lot. You will feel electrical engineering is very tough, because they are using different dimensions, and the thing, there are so many what you say, glitches and technical errors, and they are not rectifying it also, because it's working in the market and they are like selling it like. So you purchase one book like Charles Alexander Sadico, and this, or you purchase DC Kurukshetra, this book. This will do good. This is a good book. It's written by an IIT professor. This book PDF I will give you, no problem. Okay, this PDF I will share with you, and notes and everything are there. So, did you understand in today's class, Vakas? Did you follow,
Yes, sir. Yes, sir. I understood.
or you were playing the music
Sir,
which
no.
you were playing in the very beginning? I am very sharp. You know what?
Actually, sir, there was alarm.
Basically,
I'm sorry
I
for
am
that.
from defense background. My father was in defense, so we have certain intuition towards it. Thank you very much for this class, and I'll wind up the class. Thanks a lot.
Thank you.
Thank you.
Okay,
Thank you.
you can have a rest and you can
Thank
join for the other. Thank you. Thank you very much. I'll stop recording. Okay.